For centuries, humanity has looked up at the night sky and asked the same question. Are we alone in the universe? With trillions of stars and billions of galaxies, the odds seem clear. Life should be everywhere. And yet, silence. This contradiction is known as the Fermi paradox, and one possible answer to it is as chilling as it is profound: the Great Filter. It's the idea that somewhere along the journey from lifeless matter to spacefaring civilizations, there exists a nearly impossible barrier, a filter that stops life from advancing. So what is the Great Filter? And what does it mean for the future of humanity? The paradox. The paradox begins with numbers. Our galaxy, the Milky Way, holds about 100 to 400 billion stars. Many of those stars have planets, and a surprising number are in the habitable zone, where liquid water can exist. Even if only a small fraction of those planets develop life, the universe should be teeming with civilizations. Statistically, the universe should be alive with signals, spacecraft, or megastructures. But when we look, nothing. Radio telescopes listen to the cosmos. Space probes explore our solar system. Still no trace of advanced life. That's where the Great Filter comes in. What is the Great Filter? The Great Filter is a concept introduced by economist Robin Hanson in the 1990s. It suggests that at some stage in the progression from simple molecules to advanced spacefaring civilizations, there is a step so improbable that almost no one gets past it. Think of it as a cosmic obstacle course, where nearly every participant fails. The filter could be behind us, meaning humanity has already passed it; ahead of us, meaning we haven't reached it yet. Which option is true changes everything. Possible filters behind us. If the Great Filter lies in the past, then we are extraordinarily lucky survivors. Let's look at possible candidates. The origin of life, abiogenesis. The leap from non-living chemistry to living cells may be unimaginably rare. Earth could be one of the only places in the universe where it happened. Complex cells. For billions of years, life on Earth remained single-celled. The jump to complex cells with nuclei, mitochondria, and specialization might be vanishingly unlikely. Multicellular organisms. Even after complex cells emerged, life remained microscopic for ages. The leap to large multicellular organisms may itself be a filter. Intelligent life. Dinosaurs ruled Earth for 160 million years, but never built radios. Intelligence with technology may be a cosmic fluke. If the Great Filter is behind us, humanity is a miracle. The rare exception in an empty universe. Possible filters ahead. But what if the filter lies in our future? That possibility is far more terrifying. Self-destruction. Civilizations may consistently destroy themselves once they reach nuclear, biological, or AI technologies. War, climate collapse, or engineered pandemics could end progress before space colonization begins. Cosmic catastrophes. Gamma-ray bursts, asteroid impacts, or supernovae could wipe out civilizations before they expand. Resource limits. Perhaps expanding beyond one planet is far harder than we imagine. The energy, resources, or time required to colonize space might exceed what civilizations can achieve. Unknown barriers. There may be fundamental laws of physics or biology that prevent interstellar empires. Maybe faster than light travel is truly impossible, and without it, expansion stalls. If the Great Filter is ahead, humanity may be doomed to fail like all the others. Why the silence is worrisome. Astronomer Robin Hanson and others argue that the silence of the universe is a bad sign. If the galaxy were filled with thriving civilizations, we should have seen evidence by now. Giant structures, signals, colonized worlds. The fact that we haven't suggests that almost everyone fails. If life is common, then something ahead must destroy nearly all civilizations before they spread. This means every silent night sky is a warning. The filter may be waiting for us. Signs of hope. But it's not all doom. There are reasons to believe the filter may already be behind us. If abiogenesis is rare, then Earth may truly be unique. The absence of alien visitors could mean we've already won the cosmic lottery. And that would mean humanity's future could be limitless if we avoid destroying ourselves. Implications for humanity. So what does the Great Filter mean for us? If it's behind us, our task is survival, preserving our civilization and spreading to the stars. If it's ahead of us, then we must identify the threats and overcome them. Nuclear war, runaway AI, climate change. Either way, the message is clear. Our choices today may determine whether we become a multiplanetary species or just another footnote in cosmic history. Are we alone? Ultimately, the Great Filter reframes the question of alien life. If we discover even simple microbes on Mars, Europa, or Enceladus, it could mean life arises easily. And if life is common, then the filter almost certainly lies ahead. Paradoxically, finding extraterrestrial life would be bad news for us. On the other hand, if the universe is truly silent and sterile, it may mean we've already beaten the odds. Conclusion: the Great Filter is not just a scientific idea, it's a mirror held up to humanity. It asks us, will we pass through the barriers that stopped others, or will we perish like countless unseen civilizations before us? One thing is certain: the universe is vast, but our survival depends on the choices we make in the coming centuries. The Great Filter reminds us that the future is not guaranteed, but it is still within our hands.